On graphing transformations of functions. We're going to break this up into 3 videos. The first 2 videos are going to be on rigid transformations, and the last video is going to be on non-rigid transformations. So when we talk about rigid transformations, we're talking about transformations which leave the size and shape of the graph unchanged, right? So we're talking about mathematical operations that we're doing to the equation that defines the graph of the function, right? Which are moving the equation or that graph around the xy axis, maybe flipping it, changing the orientation, but not changing the shape itself. All right, so right here, the first rigid transformation we're going to look at is a horizontal shift. We're going to say a horizontal shift is a translation along the x-axis that occurs when a constant is added or subtracted inside the function. When we talk about adding or subtracting inside the function, really we're talking about adding or subtracting directly to x. So right here, let's say we've got a function f of x, right? Defining some graph, and we see the constant c subtracted within the function f directly from the x value. We would say that this would take the function and move it c units to the right. Now this might be a little counterintuitive because the right is the positive direction and we are subtracting within the function. Let's take a look at what's happening here. So in our example, we've got f of x as x cubed, and we are looking at what happens when we subtract 3 inside the function directly from the x. So right here, let's say we've got the x value of 0. When we plug that into our function, we're going to get 0 cubed or 0, which tells us that 0, 0 is an ordered pair on the graph of our cube. For the x value of 0, we get the function value of 0. What we can ask ourselves with f of x minus 3 is, what is the x value that I need to plug in order for the cube to evaluate 0, right? So what am I going to need to plug in order for f to evaluate 0? Remember, f is just the cube itself, right? So right here, what we can see is that I'm actually going to have to plug in the x value of 3 in order to get 0 within the cube, allowing me to evaluate that 0 and get 0. So actually, we're now seeing the function value of 0 happen at the x value of positive 3. And essentially what we can say here is that the function of the cube now thinks that the origin, or 0, is happening at the x value of 3. And so, what we're really seeing here is that happen for every single ordered pair on the graph of the cube, right? Every single ordered pair on the graph of the cube, the function now thinks is happening 3 units to the right in the positive direction, right? To compensate for that subtraction of 3 within the function. If we're looking at adding a constant c within our function, we would say that that moves the function c units to the left, which is of course the negative direction. Again, right here we can see that ordered pair 0, 0. For an x value of 0, we're getting the function value of 0 on the graph of the cube. And we can ask ourselves that same question we did above, right here. What is the x value I'm going to need to plug into x plus 2 cubed in order for the cube to evaluate 0, right? So what's the x value I'm going to need to plug in order to get 0 here? And we can see here that that would be the x value of negative 2, right? So basically at this point we can say that the function thinks that the origin is now happening at negative 2 when we add 2 within the function, right? And we're actually getting right here the ordered pair, negative 2, 0, on the function of x plus 2 cubed. Now, right here, again, that's happening for every single ordered pair on the graph of the cube, and we're seeing every single ordered pair on the graph of the cube move 2 units to the left, and that's 2 units in the negative direction. In general, what we want to think here is adding or subtracting directly to x, and that's inside the function. Don't really need a period there. Is a horizontal, so is a horizontal shift in the opposite direction. Now, you may not need to write all that down, but that's the general way we want to think about what's happening when we add or subtract directly to x inside the function. An addition or subtraction is going to be a horizontal shift in the opposite direction when we are adding or subtracting inside the function, and that's directly to the x. Okay, so let's look at vertical shifts. Right here we say a vertical shift is a translation along the y-axis, occurs when a constant is added or subtracted outside the function, right? Now, right here, these are a little bit easier to interpret. Right here we've got f of x as our function, right? And we're saying we are adding the constant c outside the function directly to the equation, right? We would say that this would take the function and move it c units up on the graph. And we might say on the graph being, that part of the graph being the y-axis. Right here, x cubed is defining the y values of the function, right? So basically, every time I plug in an x value, what defines that y value is the cube itself, right? So when I take a look at adding a constant, let's say 2, to the cube, really what I'm seeing is y plus 2 for all of the y values, right? So here we have ordered pairs that are x, y. And in the case of adding 2, we're seeing ordered pairs that are x and then y plus 2. So right here, basically what we're seeing is the graph of the 2 with 2 units added to every y value, and that's going to shift us up 2. I'm going to erase that a little bit so that I don't go over my 2 there. So I'm seeing my whole graph move 2 units up on the y-axis because I'm adding 2 to every y value, right? And this, of course, is the vertical shift up 2. Now, right here, when I am subtracting from my function, right, so the same f of x, if I say minus c outside the function, we would say that that takes the function and moves it c units down on the graph. And again, the graph, we're talking about the y-axis. So right here, again, we've got the cube defining our y values, and we're subtracting 1 from the function, subtracting 1 from the cube, which means we're subtracting 1 from all the y values. And again, very intuitively, we can see that right here, we are taking the graph of the cube, right, and subtracting 2 from all of the y values, bringing our function down 1. So right here, again, for our ordered pairs x, y, now we have ordered pairs that look like x and then y minus 1, and that moves our entire function down 1 on the y-axis. So right here we can say, adding or subtracting, outside the function. Oh, I need a period. And that's directly to the equation, is a vertical, I'm going to abbreviate, vertical vert shift in the same direction. So basically what we're seeing is if we're adding, then we're going to be moving up. If we're subtracting, we're going to be moving down, right? As opposed to that horizontal relationship where when we add, we're moving in the negative direction, and when we subtract, we're moving in the positive direction horizontally. Okay, so we got a problem for you guys to try right here. We've got the function f of x as the absolute value function, and we are adding 2 inside the absolute value and subtracting 3 on the outside. And what I want you to do is to evaluate the transformations, or evaluate basically the graph of g, right, by looking at these transformations. So we're taking the graph of f, which is the absolute value, and evaluating the transformations that the addition of 2 inside and the subtraction of 3 outside will give. So why don't we pause the video and give this a shot. Okay, so right here, we've got the graph of f, and what we can see is from that addition of 2 inside the function, we are redefining where the absolute value thinks the origin is. Now it's going to think that the origin is happening 2 units to the left in the negative direction, right? And then we take all of the y values that the absolute value of x plus 2 gives us and subtract 3 from all of those y values, moving our graph down 3. And that gives us this g as the graph of our function. Okay, guys, this is the end of this video. First video is pretty short. Why don't you press stop here and jump to the next video.